There was a moment when someone asked Richard Feynman a question that sounded almost childish in its simplicity. It was not aggressive. It was not technical. It was not even complicated. It was the kind of question people ask every day, the kind that feels so obvious it almost answers itself. And yet Feynman refused to answer it, not because he did not know physics, not because he lacked intelligence, not because he wanted to be mysterious. He refused because the question itself carried a hidden trap. That is what makes this story unsettling. We are used to scientists being explainers. Their role in the public imagination is to translate the universe into digestible clarity. If something moves, they tell us why. If something attracts, they tell us why. If something exists, they tell us why. Science, we assume, is in the business of answering questions. So when one of the greatest physicists of the 20th century declines to answer a simple why something feels wrong, the question in various forms often sounded like this: why does this happen? Why do magnets attract? Why does nature behave this way? Why is there this rule instead of another? On the surface, it seems harmless, but underneath that surface, the expectation is that every phenomenon must have a deeper reason that can be explained in familiar terms. We want the universe to justify itself in language we already understand. This expectation feels reasonable because that is how explanations usually work in everyday life. If someone asks why a glass fell, you say someone knocked it over. If they ask why someone knocked it over, you say they tripped. If they ask why they tripped, you explain they didn't see the step. Each answer reduces the unknown into something already known. We assume physics works the same way, but physics is not merely rearranging familiar causes. It eventually reaches a level where the explanation stops reducing and starts describing. And this is where the tension begins. When Feynman refused to answer, what disturbed people was not silence. It was what that silence implied. It implied that the question may not be pointing toward a deeper story. It may be pointing toward the edge of explanation itself. There is something psychologically uncomfortable about that possibility. We are conditioned to believe that intelligence means having answers. Refusal sounds like ignorance. Yet Feynman was not ignorant. He was careful. The simplicity of the question is what makes it dangerous. Simple questions often carry hidden assumptions about how the world should work. They assume that nature must align with our mental categories. They assume that Y always has the same structure. But what if it doesn't? What if the question is asking for a type of explanation that physics does not provide? Feynman understood something that many people resist. Not every question has an answer in the form we want. Some questions dissolve when examined closely. Others expose the limits of language rather than the limits of knowledge. The refusal, then, was not dismissive. It was precise. Instead of pretending to satisfy curiosity with comforting narratives, he chose intellectual honesty. And that honesty felt unsettling because it removed something we rely on. The belief that reality can always be translated into human-scale reasoning. At this point, the mystery shifts. The real puzzle is no longer the scientific phenomenon. The puzzle becomes the question itself. Why did we expect an answer in the first place? That is where this story truly begins. When most people ask why, they believe they are asking for a cause. But very often they are asking for something else entirely. They are asking for a story that feels complete, a story that replaces mystery with familiarity. This distinction is subtle, and it is where confusion begins. In everyday life, why usually means what caused this to happen. Why did the glass break? Why did it fall? Because someone pushed it. Each answer moves backward in a chain of events. Eventually, the chain reaches something we accept without further demand. That stopping point feels natural, and so the explanation feels satisfying. Physics can answer many questions in this way. Why does an object fall? Because gravity pulls it toward the Earth. Why does gravity pull it? Because masses curve space-time. At first glance, the pattern seems identical to everyday reasoning. But something important changes as we go deeper. When someone asks Feynman, why do magnets attract? They are often not asking for a description of electromagnetic fields. They are asking why the universe contains such fields at all. They are asking why nature chose this rule instead of another. They are asking for an ultimate reason. And that is where the word why begins to stretch beyond what physics can deliver. Feynman famously responded to such questions by saying that he could describe how magnets attract in terms of fields and forces. But if you then ask why those laws are true, you are stepping outside the structure of physics. The explanation will eventually reach a level where it no longer reduces to something more familiar. It becomes foundational. At that point, physics does not provide a deeper mechanism. It provides equations that consistently predict outcomes. The laws work, they are tested, they are reliable, but they do not explain themselves in terms simpler than themselves. This frustrates people because it violates expectation. We assume that explanations must always move towards something more intuitive. We expect a final layer where everything suddenly makes sense in everyday language. But nature is not obligated to end at a level comfortable for human imagination. The problem is not that science refuses to answer. It is that we sometimes ask a question that quietly demands metaphysical justification. We want to know not just how something behaves, but why reality is structured that way. That kind of why may not have a scientific answer at all. There is a critical difference between causal explanation and ultimate explanation. Causal explanation traces relationships within the system. Ultimate explanation asks why the system exists in its current form. Physics is powerful within the first category. In the second, it becomes silent. This silence is not ignorance. It is boundary recognition. When Feynman refused to answer, he was not dodging the question. He was identifying which kind of why was being asked. If the question is about mechanism, physics can respond. If the question is about ultimate purpose or necessity, physics reaches its edge. Many people blur these two meanings together. They think if a scientist can explain how something works, they should also explain why it exists in the first place. But that leap is not logically guaranteed. The discomfort comes from realizing that some of our deepest questions may not have the type of answers. We want the universe to justify itself. Physics describes it instead. Feynman understood that pretending to answer beyond that boundary would create the illusion of understanding without the substance. He preferred clarity over comfort. And once you recognize the two different meanings of why, his refusal begins to look less like avoidance and more like precision. Feynman's refusal was not theatrical. It was not a performance of mystery. It was a refusal rooted in discipline. He understood something dangerous about explanations. They can feel satisfying long before they are true. Many scientists, especially in public settings, are tempted to smooth over the rough edges of knowledge. Audiences want clarity. They want resolution. They want the sense that the world is fully accounted for. It is easy to slide from what the equations say into what sounds like a deeper story. Feynman resisted that slide. When asked why something happens at the most fundamental level, he would often pause and redirect. Not because he lacked curiosity, but because he respected it. He believed curiosity deserved accuracy, not decoration. This is where the contrast becomes sharp. On one side, there is the storyteller's impulse. Take a complex idea and translate it into familiar metaphors. On the other side, there is intellectual honesty. Admit when the metaphor stops being equivalent to the mathematics. Feynman knew that language can create the illusion of understanding. You can say that particles want to move a certain way, or that nature prefers certain arrangements. These phrases feel explanatory. They give human qualities to impersonal laws, but they do not add information. They simply repackage the unknown in more comfortable words. He was uncomfortable with that. To him, that's just how the law's work was not a failure. It was a recognition that explanation bottoms out somewhere. Every chain of reasoning eventually reaches principles that are not explained by deeper mechanisms within the same framework. For many people, this feels unsatisfying. It feels like stopping too soon. But Feynman understood that going further without evidence is not deeper understanding. It is speculation disguised as insight. His honesty was unsettling because it exposed a gap between what people expect science to provide and what science actually provides. We often imagine that the greatest minds must possess a hidden final answer, a secret explanation beneath the equations. When Feynman declined to invent one, it felt like withholding. In reality, it was restraint. He once emphasized that the value of science lies in its uncertainty. Not knowing is not a weakness. It is the starting point of discovery. Pretending to know closes the door that uncertainty keeps open. This attitude requires confidence. It is easier to provide an answer than to explain why the question exceeds current knowledge. It is easier to construct a narrative than to draw a boundary. Feynman chose the harder route. His refusal also protected something essential about physics, its commitment to testability. Once you move beyond describing how laws behave and begin explaining why those laws exist in ultimate terms, you step into territory that cannot be experimentally verified. The discipline shifts from physics to philosophy. There is nothing wrong with philosophy, but confusing the two weakens both. Feynman's intellectual honesty reminds us that explanation has levels. At some point, the most truthful answer is not a story, but a statement. This is the rule. It works, we can measure it, we can predict with it. Beyond that, we do not yet know. The courage to say that is rare. In a culture that equates expertise with omniscience, admitting limits feels like vulnerability, yet Feynman's refusal was not vulnerability. It was strength. It preserved the integrity of inquiry. And it forces a deeper realization. The boundary of explanation is not a flaw in physics. It may be a feature of knowledge itself. Every explanation eventually reaches a floor. At first, that statement feels disappointing. We prefer to imagine that knowledge is an endless staircase, that for every why there is always a deeper because. But if you follow any chain of reasoning carefully enough, you discover that it does not descend forever. It stops at principles that are taken as given. In physics, those principles are the fundamental laws. If you ask why objects fall, physics explains gravity. If you ask why gravity behaves as it does, physics explains space-time curvature. If you ask why space-time follows those equations, you reach the edge. The equations describe reality with extraordinary precision, but they do not explain themselves in simpler terms within the same framework. This is not laziness, it is structure. Explanations work by reducing unfamiliar phenomena to more familiar ones. But once you arrive at the most basic layer, there is nothing more fundamental within that system to reduce to. The chain ends not because curiosity fails, but because the framework has reached its base. The problem is that human curiosity does not naturally stop at frameworks. It keeps asking, why these laws? Why these constants? Why this universe? At that point, the question is no longer scientific in the ordinary sense. It has stepped beyond empirical description into metaphysical territory. Physics can tell you how the constants behave, how the laws interact, how the universe evolves under those rules. It cannot tell you why those rules exist rather than others. Feynman understood that pressing further with the same tone of certainty would be misleading. The boundary is not arbitrary. It is built into how explanation works. There is a recursive nature to why. Each answer invites another question, but recursion cannot proceed infinitely within a finite system. Either it ends in brute facts, statements that are simply the case, or it shifts into speculation beyond testable evidence. Many people find brute facts unsettling. They prefer a universe that ultimately explains itself. But even the idea of self-explanation runs into limits. Any explanation must begin somewhere. Feynman's refusal, then, was not about ignorance of magnetism or gravity. It was about recognizing that at the deepest level, physics offers models that match observation. It does not offer ultimate justification. This does not weaken science. It clarifies its role. Science describes patterns in nature and builds predictive framework. It does not assign purpose or necessity beyond those patterns. When people demand a final why, they are often asking for something outside the scientific method. The honesty lies in saying so. The discomfort comes from confronting the possibility that reality might not provide the kind of closure we instinctively seek. There may not be a deeper narrative beneath the laws, at least not one accessible to experiment. That realization feels like an absence. In truth, it is a boundary, and boundaries are not failures. They define the domain where knowledge is reliable. Feynman refused to blur that boundary for the sake of comfort. In doing so, he revealed something profound. Understanding does not mean dissolving every mystery. Sometimes it means recognizing which mysteries belong to physics and which lie beyond its reach. By the time we reach the end of this story, something subtle has shifted. The mystery is no longer why Feynman refused to answer. The mystery is why we expected him to. When we hear a simple why, we assume the universe owes us clarity. We assume reality must be structured in a way that can be translated into human language without remainder. We rarely question that expectation. It feels natural, even rational. But the demand for ultimate explanation may reveal more about us than about physics. Humans are pattern-seeking creatures. We survive by compressing complexity into stories. Fire burns because it is hot. People act because they desire things. Objects fall because something pulls them. Each explanation gives us a sense of closure. Closure reduces anxiety. It makes the world feel manageable. So when physics reaches a point where it says, this is the law, beyond this we do not know, it interrupts that psychological comfort. It refuses closure, and that refusal can feel like failure. But perhaps the failure is not in the answer. Perhaps it is in the expectation. Feynman's refusal forces us to confront a deeper possibility. That explanation is not infinite. That knowledge has layers, and at the base of those layers there may be facts that simply are. Not because they were chosen, not because they serve a purpose, but because they are the structure of reality as we currently understand it. This is not a defeat of curiosity. It is an invitation to refine it. Instead of asking why the laws exist in ultimate terms, we can ask how they connect, how they unify, how they might emerge from deeper frameworks still under investigation. Science progresses not by demanding final answers, but by sharpening questions that can be tested. The emotional shift is important. Frustration turns into humility. The desire for narrative turns into respect for limits. The silence where we expected explanation becomes a reminder that knowledge is not synonymous with certainty. Feynman's strength was not that he had answers to everything. It was that he was unwilling to pretend he did. That refusal protected something fragile, intellectual integrity. In a world that often rewards confidence over accuracy, admitting limits is rare. Yet those limits are where real inquiry begins. When we recognize that some why questions exceed current frameworks, we stop confusing speculation with understanding. And something surprising happens. The absence of a final answer does not shrink the universe, it makes it larger. The laws of physics remain astonishingly powerful. They describe motion, fields, energy, and matter with breathtaking precision. They allow us to predict eclipses, build satellites, and probe subatomic particles. But they do not narrate their own necessity. Perhaps that is enough. The question that Feynman refused ultimately turns back on us. Do we want truth even when it is incomplete, or do we want comfort disguised as explanation? The honest answer to that question determines how we approach knowledge itself. Feynman chose truth, not the comforting kind, the careful kind. And in doing so, he left us with something more valuable than a satisfying answer. He left us with a model of intellectual courage, the willingness to stand at the edge of explanation and say clearly and without apology, this is as far as we can go. For now,